So it says 42.
Gravity more than
Okay, so, okay. Okay.
I can do this.
As I said to Logan, hey, this is an example where you've got to be very careful to not mix up amount versus rate. I'll keep reminding you about this until May 4th. Read the problem. Don't do like you've done on the ACT and you've done in lots of previous classes where you just kind of glance at the problem and try to grab key facts. You'll get it wrong. Like, read it and comprehend it. I've seen it happen over and over again. It says the radius of a circle is increasing at a non-zero rate. So there they are not, I mean, they're talking about the amount and the rate at the same time, I guess. They're saying the circle has a radius, which is kind of not needed to be stated. All circles have radius. So they have that. There we go. And they say that radius is increasing at a non-zero rate. I don't know why they say non-zero. It's just to mess with you.
It's increasing, non-zero.
Yeah, I would vote with that. Yeah, they do that in on purpose, just to, you know. Yeah. It says at a certain instant the rate of increase of the area. So there's some area of the circle, and at some instant the rate of increase of the area. So now they're talking about dAdt. Okay, all related rate problems. Hey, all related rate problems talk about something that is changing. It's almost always geometric. Not always, but most of the time. So here we have a circle, and the circle is increasing. Great, exciting. Back to the Brian Regan joke. The big yellow one is the sun. So, and then, look, hey, the idea is not that the rate, you know, this just grows forever according to the problem. But at some moment, they tell us that these two things are the same. The RDT, so at some instant, the RDT is going to equal dAdt, but only at some instant.
It's the circumference, not the...
Ah, shoot. Thank you. Clever. So there you have circumference and dCdt. Got distracted by the sun. Okay, here's the caution. Look. Come on. Focus. Here's the caution. Don't assume this is true always. It's not. It's only true at the special instant that they're referring to. Everyone with me? Okay. So I've got my Danikus chart build. I've read the problem. It says write down an equation using the amounts. Here's what makes this problem different than all the other related rate problems you have solved so far. This problem is describing three different amounts. There is no single equation that relates the three. So not common in a related rate problem, but also not like unique. I've seen it before. I need two equations. I need the equation for area, and I also need the equation for circumference. Those you must have memorized. They won't ever give those to you. Question. So now I take the derivative of both equations with respect to time. So I end up with dAdt pi 2r the RDT. And then also dCdt 2 pi dr dt. Okay, questions? So I finished with the dread process. Now I have to somehow figure out how do these equations, which I created using the dread process, the purple equation and the green equation, how do those help me somehow find whatever it is they want me to find? I'm looking for the radius of the circle. So pay points now. Hands up. What do I do next? Now what? Every problem's different from this point on. You just have to be good at using the equal sign and identify what's the same as what to help you solve the problem. Get about half of you. Anybody else? Trying to find somebody new. Let's go, Nelson.
Well, we know that DC is equal to dA. It's very strong, but yeah, just set the two values equal to each other. It's all broad.
So this is the same as this, which means this is the same as this. Hands up if you knew it. 2 points, 3 for Nelson. Now I can write down 2 pi r dr dt is 2 pi dr dt. I would simply divide both sides by 2 pi dr dt. Everything is factored, so division is easy. So r is equal to, oh, it's my favorite number again.
1/2 or 1.
There's a song about that from the late 70s. 1 is the loneliest number. Okay. Yeah, you've heard it. Questions? Good work. See ya. Finish the green, please. All right.